All right, this is going to be a video on angles outside of a circle when you have different things intersecting, different kinds of segments and lines intersecting. First, let's remind ourselves what a tangent is. A tangent is a line that intersects a circle at one point. And I always tell my students, we want to remember tangent touches. So a tangent touches. When we get to the secant is a line or segment that's going to intersect the circle at 2 points. This term here is going to be a secant slices. Secant slices. Tangent touches, secant slices. So your tangent's going to brush up against, just touch that circle barely. The secant's going to slice through it. So here you have your three different intersections. When we have angles outside the circle, you've got two tangents, you've got a secant, two secants, and you have one of each, the secant and the tangent. So here in the first section, we're going to go ahead and name the angles formed because we're dealing with angles and we're dealing with arcs now. Not measuring the actual secants and secant segments and tangent segments, but now we're dealing with angles and we're dealing with arcs. So here we want to name the angle formed by the tangent line. So we have line AB and line CB. The angle that is going to be formed is going to be angle ABC. So we have angle ABC. We want to name the two arcs that are formed. There's going to be one that is going to be closer and one that's going to be further away from this angle that we talked about. So we have here arc AC, which is going to end up being a minor arc. So the other one's going to be a major arc with two tangents. So we can't name it AC. We're going to have to pick up the point D on the way. So we could call it arc ABC. Remember our arc notation. Now we have two secants, okay? So here we're going to name the angle formed by the secant lines. Well, same thing here. We're going to go bam, bam. The vertex is at F. Whether you use D or E does not matter. Then whether you use G or H, it does not matter. I just typically go for the furthest away. So we have angle D, F, G. Now it wants to know the two arcs that are formed. So here closer to it we have arc EH, and because the other arc does not have a point, we can go ahead and assume this is going to be a minor arc, arc DG. Now again, if you want to call it arc GD, you can as well, but these are our two arcs that we're dealing with, and these arcs and angles are going to be very, very important. Okay. Lastly, here we have a secant up top, and we have the tangent down here. Line IK is going to be your secant, and line LK is going to be your tangent. Name the angle formed. Well, again, the vertex is over here at K, so I'm going to name it angle IKL. Remembering that K, the vertex, has to be that center letter. Now we're going to name the two arcs. Now, we also, and I didn't point this on the secant, but you got to understand there's two other arcs on the secant. Here there's another arc. We're dealing with the two arcs that are formed inside of this angle. Okay, so we have inside the angle. So we're looking at all within this area, not outside. So here we have arc JL, and the other side we have arc IL or LI, whichever order you'd like to put those two letters. Okay, so we're talking about these pictures here, these diagrams. The questions below are asking, A, for each example, what do you notice about each angle's location relative to the circle? Well, if we take a look at this, we'll go ahead and put A. We're going to answer A. Each one of these angles is located outside. And in further notes, you'll understand why this is important. So we can put in here, angles are all outside the circle. Angles are all outside the circle. Please pause and get that finished. B is asking, what do you notice about the size difference for the arcs? Look at E, and I even made a comment earlier about minor and major. If you look at this, let's see, first of all, let's notice all the angles in these diagrams are on the right. Look at the left arc and the right arc. Left arc, right arc, left arc, right arc. We should be noticing that the arc closest to the angle is smaller. So the one over here, and I'm saying closest, not to the right, because they're not always on the right, but the arc that is closest to the angle is smaller. And we can just leave it at that. It's going to be the smaller one. All right? So when we're dealing with these angles outside of the circle, no matter what two segments are, I guess in this case rays, two tangents, two secants, or tangent to secant, whichever ones that are intersecting, you've got a formula, nice, like we do with all these circle things. You have this nice formula saying the measure of the outside angle, so the measure of this angle right here, ABC, DFG, IKL, the actual angle. You're going to take the bigger arc, subtract the smaller arc, and divide by 2. So subtract the smaller number from the bigger, divide by 2. So let's take a look at some examples here. The first one here, solve for x. Okay, well, x is going to be the angle. Well, our formula was the measure of the angle is going to be outside arc minus, well, I guess you could put big arc. That's what we had. Big arc minus small arc divided by 2. And the big arc will be the outside. So it will be the outside arc minus the inside arc. So here, our angle, which is x, is going to be equal to the bigger arc, the furthest one outside, 140, minus the smaller arc, 50, all divided by 2. And whether we want to take it one step at a time, 140 minus 50 is going to give you 90 divided by 2. So x is going to equal 45 degrees. Okay, nice, simple, and sweet. So let's take a look at this next one. We had two secants. Okay, so the two secants, we're going to have to be given some information. In this case, they gave us both the arcs. Now, what happens if they don't give us both the arcs? On number 2, we're going to notice here that we have two tangents. The tangents touch. They don't slice through. So we have the smaller arc. We need the bigger arc. So to find this bigger arc, because they're two tangents, the whole thing is 360. From one tangent to the other, one point of tangency to the other, we have 150. So we just need to take that 360, subtract the 150, and we find out that, because I could put this arrow here, that the bigger arc is going to be 210. So now we can solve for the angle. The angle, okay, x is equal to the big arc, 210, minus the small arc, 150, all divided by 2. And if we do the subtraction first, we end up with 60 over 2. X is going to be equal to 30 degrees. All right, let's step it up a notch. We now have the angle. We're missing an arc, so we're going to have to work backwards on this one. So let's watch very, very carefully what happens on this because it's the smaller arc that we're missing. We're still going to use the same formula. The angle, okay, so here the angle is equal to the big arc minus the small arc divided by 2. Well, the angle measurement is 40 degrees. So we're going to have 40 equals, we want the big arc, which we have, 150, the furthest one from the angle, minus the small arc, which is that x, all over 2. We can work this proportion, set 40 over 1 and cross multiply, or doing the exact same thing we've learned before. If you want to get rid of the denominator, multiply both sides by it. So these cancel, and we have 80 equals 150 minus x. We need to get the 150 away from x, so watch what happens. We're going to, not add, we're going to subtract that 150 from both sides, and be careful. Number 1, 80 minus 150, you're going to get a negative. It's going to wind up being negative 70 equals, do not forget, this is a minus x, so you need to bring down negative x. And we have that negative x. All we have to do is divide both sides by a negative 1, change the sign of both sides, and then your x ends up being 70. So that's the toughest part, is having that negative there sometimes. All right, so let's take a look what happens now. Again, stepping it up yet another notch. All right, no big deal. We got 2 more. We're going to get through this. We're going to take the angle measurement, which is right here, of x plus 25. So we're going to have x plus 25. Set that equal to the larger angle. Okay, maybe we should be putting B and S for, well, I don't want to put BS, but big and small. Okay, So we have our big angle, 4x plus 10. Okay. Then we're going to subtract the small angle, 50, all over 2. I'm going to hit two birds with one stone. I'm going to not only, I'm going to go ahead and combine my like terms up here. I have a positive 50 and positive 10, negative 50. And this is going to bring me down to 4x. Did I put those right? 10, 50, yeah. 4x, and we're going to have minus 40. But I'm also going to get rid of the denominator at the same time. Okay, you don't have to. But I was getting rid of them at the same time here. What we do to one side, we have to do to the other. Now I end up having distribution on the left-hand side. This happens, okay? We just do our, even though if you want to put parentheses here, please do. Distribute 2 to the x, we get 2x. Distribute the 2 to the plus 25, we get plus 50. Now we just have our 2 steps. Please pause it and work it out on your own. I'm going to go very quickly and then move on to save time on the video. Move my variable. Get 50 equals 2x minus 40. It's very sloppy. Sorry, that's what happens when you rush. Add the 40 to both sides. I'm going to wind up with, move myself over here, we're going to have 90 equals 2x. I'm just rewriting it so I have room. Divide both sides by that 2. And x is going to wind up equaling 45. Okay, please go back and watch that again if you need to, especially because of that first part. All right, example number 5. Ooh, I do not like that big arc there. We're going to clean this big arc up before I go moving it into our equation. I have to clean this up. The first thing I'm going to do is I'm going to take care of this distribution right here, just the 2 parentheses 6x plus 5. When I take care of this distribution, 2 times 12, I just gave it as a 2 times 6x, I'm going to get 12x. 2 times a plus 5, I'm going to get plus 10. Then I'm going to go ahead and bring down this plus 3. Note that plus 3 is not in with the distribution. Extremely important to understand. Okay, he's off to the side after distribution, and that's what I'm going to take care of now. Now I have combining like terms. Doing a lot of math beforehand. And then I'm going to wind up with a 12x plus 13. Now, none of this matters anymore. I'm going to be using the 12x plus 13 for my big arc. 5x is going to be my small arc, and the 66 degrees is going to be the angle. So, again, we've got our angle equals, so 66 equals big arc, 12x plus 13, minus small arc, 5x, all over 2. Okay, I have clean up on our numerator here. And I also need to get rid of the denominator, so I'm going to do this, and I'm going to hit 2 birds with 1 stone again on this one. Okay? Here I'm going to wind up combining the 12x and the minus 5. That's why I always box those. So I usually circle those, but I always include that plus or minus, okay? Because on this side, I'm going to wind up with a 7x. Move that up a little bit. I'm going to wind up with a 7x. And then nothing's going on with the 13. We're just going to slacken them to the end, plus 13. Now, when I multiply both sides by 2, again, it just cancels. But what I do to one side, I have to do to the other. That's why I didn't write the 66 yet. 2 times the 66 will get me 132. Last 2 steps. Subtract the 13, divide by 7. We subtract the 13. We wind up with 119 equals 7x. Divide by that 7. Our x is going to end up equaling 17. A lot of different kinds of problems. Yes, they got gruesome, okay, but you have to know how to do all of this. Please ask your teachers if you have any questions, or again, you can go onto YouTube and search for more videos. Just type in angles on the outside of circles.